And so in this project, we did those boat physics in VR where we had an oar and you can push yourself off the environment and everything.
So for the oar, we just have simple game object with a mesh. And what is actually used in the physics is the position of the paddle. The paddle has a separate script on it that then interacts with the boat script, and that is used to actually create some forces on the boat so it can actually move. So if we take the oar, we can take it, we can hit the boat without actually moving the boat, but still interacting with the physics. So that is done by adding another kinematic rigid body that we move ourselves, and that just interacts with the oar and nothing else. Otherwise, if I would just have the boat, which is a rigid body which we apply forces to actually move it, the problem is if I would hit this with the oar, if I do this, the boat would start moving, and probably quite fast, because we can put a lot of force on it, much more than what the physics allow. So there is one rigid body that actually does all the movements, and then we just have another rigid body that's completely kinematic, and the only thing it does is it sets its position the same as the other rigid body. So that way we can interact with the boat, with the paddle, realistically without moving the boat. The paddle, if it's under the water, the oculus starts vibrating, so we can actually feel that we're doing something. It was very important to have that feedback, otherwise you didn't know if you were far enough with the oar in the water to react with it. The boat itself is a rigid body, and we apply all the things on this rigid body, all the forces on this rigid body. When we use the oar in the water, it is actually the relative velocity by which the oar moves in the water that determines the force on that frame, and then in that frame we apply that force to the rigid body relative to the water. So if the boat is moving forward and you put your oar in the water, you will still rotate.
And one frame the oar will be at one position in the world, and the next frame it will be somewhere else because you're moving.
You also don't want to go through the physics. So what we do, if you actually look at the hand while I'm pushing it, is that the hand actually is with a kind of rubber band effect attached to the oar before we drop it. But if we go too far, the oar will still drop. Also, what's important here for the rigid body is you see that drag is set to 0, and that is because we have a very different drag in the forward direction and in the sidewards direction.
If you push a boat in the forward direction, it's of course much easier. You have a lot less drag than if you try to push it sideways.
It is calculated in the code itself, the right drag coefficient and the forward drag coefficient.
In this case, we added like 50 times more drag if you would push the boat sideways or if you would try to.
We also have water flows that can actually influence the boat. Those are simple forces that are applied to the boat. If you're within a certain collider, it starts adding a force every frame, pushing you in a certain direction. So that's just one water flow. So from the moment you're within this collider, it starts adding a force. And then it goes over into another one, the one over here. This one is set to be a bit stronger. And then we just have multiple ones that actually force you to rotate a bit so that you don't just crash into this wall here, because the water also flows like this. For the water flow things, you have a default strength and default torque factor, and then actually the ones that are defined here are other multipliers on top of that. So you have a default strength for the water flows, and then you can increase a certain water flow or make sure it turns more if you want to have a sharp corner where you need to be easily get past. Walls actually push the boat away, because what you don't want to get in the game is to get stuck with your boat against the wall. See here, I'm almost hitting the boat, and there the wall just started to push me back. So here it's also a force that is applied to the boat. There are two places where it detects it. So it's the front of the boat and the back of the boat, and then starts applying forces. This way, you're not going inside the wall with the physics, which is always possible in a game engine, of course. It's also important for VR to have not sudden accelerations or decelerations here of hitting a wall, for example, because that's very nauseating. So we actually added a maximal amount of force you could add by rowing. The controller doesn't have any resistance if I put it in the virtual water, of course. So that's why we had to put the maximum, because in the real world you wouldn't be able to get the ore that fast through the water.